Hello students, types of waves. First one is mechanical wave. These waves need medium for propagation. For example, sound wave, water wave, seismic wave. Wave during earthquake is called seismic wave, etc. Mechanical wave need medium for propagation. Next, electromagnetic wave. These waves do not need medium for propagation. Not required any medium for propagation. Electromagnetic wave. For example, light wave, visible ray, UV ray, radio wave, infrared, X-ray, etc. Next, matter wave. Waves in microscopic particles like atoms, molecules, electrons, protons, neutrons when they are in motion. Waves in microscopic particles like atoms, molecules, electrons, protons, neutrons when they are in motion. Those are called matter wave. Depending on nature of propagation, waves are categorized into two. One is transverse waves, second one is longitudinal waves. Before studying transverse wave, throw a stone in the water pond. Wave on the surface. Imagine the wave on surface. Water particle movement downwards. Look at wave on the surface. Water particle movement towards the bottom of the water. So, wave propagation, water particle propagation are perpendicular to each other. Then, such waves are called transverse waves. Look at the definition. Direction of propagation of wave and particles of the wave is perpendicular to each other. Direction of propagation of wave and particles of the wave is perpendicular to each other. Such a wave is called transverse wave. Look at the figure. Direction of particles, direction of propagation of wave. Example, light waves, water waves. Next, longitudinal wave. Look at the next figure. Wave in the spring. One's compression, one's rarefaction. Look at the figure. All the particles are come together at the compression. Particles are dispersed. It is called rarefaction. So, here you can observe the particle's direction and the wave direction are the same. Look at the definition once again. Propagation of wave and particles both are in same direction, then such a wave is called a longitudinal wave. Next, progressive wave. Waves traveling from one point to another point are called progressive waves. They do not come back. Waves traveling from one point to another point is said as progressive wave. Displacement equation of progressive wave is y equal to a sin omega t. Should keep in mind y equal to a sin omega t. Here y is displacement at time t, a is amplitude, omega is angular frequency, which is equal to 2 pi by t. Next, stationary wave. Stationary means standing position. Stationary wave. Two identical waves with the same frequency and amplitude traveling with the same velocity in opposite directions with each other. Their resultant appears to be in rest. This is called stationary wave. Once again, stationary wave, two identical waves with the same frequency and amplitude. Imagine frequency and amplitude traveling with the same velocity in opposite directions with each other. Their resultant appears to be in rest. This is called a stationary wave. Now answer. Waves need medium for propagation. What type of waves are them? Good. Mechanical waves. Not required any medium. Electromagnetic wave. Sound wave is an example of beautiful mechanical wave. In that, it is a longitudinal wave. Light wave is an example of supernova, transverse wave. Rare fractions and compressions will be there in the wave. Beautiful longitudinal wave. In the same way, what are there in transverse waves? Good. Crest and trough. Displacement of progressive wave equation is very good. Y equal to a sin omega t. What is a here? Good. Amplitude. Wherever capital A appears here in this chapter, it is amplitude only. Omega is beautiful angular frequency. Omega equal to great Nana 2 pi by capital T.